I'm making some drinks for me and my friends. Sam wants a cup of tea, Natalie wants a glass of water, and I want a glass of orange juice with some lovely cool ice cubes. The ice cubes in my glass, the water in Natalie's glass, and the steam from Sam's cup of tea are all made up of exactly the same particles. But if they're all the same stuff, what makes them behave so differently? To explain that, we're going to need a microscope to look at them all really closely. So refreshing. Here are three different states that matter can exist in: solids, liquids, and gases. Solids are things like metal, wood, and ice. If we look at them under a microscope, we can see that solids are made up of particles that are packed closely together and can't move freely. This means that a solid's shape is rigid and fixed, and can only be changed with force, like snapping a plank of wood. Liquids are things like oil, ink, and water. If we look at them under a microscope, we can see that liquids are made up of particles that are packed closely together, but can move freely. This means that a liquid takes the shape of its container and can flow from one place to another. Gases are things like air, smoke, and steam. If we look at them under a microscope, we can see that gases are made up of particles that are spaced far apart and can move freely. This means that a gas takes the shape of its container, but can also expand to fill a container too. Okay, so we've got solids, liquids, and gases. There are some materials that might seem to behave like one state of matter, but are actually a different state of matter. Here is a glass filled with sand. Now, we know that a liquid will fill the shape of its container and flow from one place to another. The sand is filling the shape of the glass it's in, and more sand can easily flow into the glass. So, is sand a liquid? No, it's not. Even though lots of grains of sand together can flow and will fill the shape of their container, the shape of each individual grain is fixed, which means that sand is a solid. We can think of grains of sand on a much bigger scale, like balls in a ball pit. Lots of balls together can flow and will fill the shape of the ball pit, but the shape of each individual ball is fixed. Other tricky examples are steam and fog. They're gases, but it's not the gas that we're seeing. Instead, we're seeing lots of tiny droplets of liquid water, known as vapour, which is being carried by the invisible gas. Let's play a game. I'm going to show you some things, and I want you to work out if they're a solid, a liquid, or a gas. Bricks. If you want, you can pause the video to give yourself more time. Solid. A brick's shape is fixed, and we can only change it with force, like breaking it. Helium in a balloon. Gas. Helium can expand to fill the shape of a balloon and scatters in the air if the balloon is popped. Pencils. Solid. A pencil shape is fixed and we can only change it with force, like snapping it in half. Vinegar. Liquid. Vinegar will take the shape of its container and can flow from one place to another. Perfume. Liquid. Perfume will take the shape of its container and can flow from one place to another. Even though perfume may look a bit like a gas when we spray it, it's actually lots of tiny liquid droplets. Sugar. Solid. Even though lots of grains of sugar together will fill the shape of their container, the shape of each individual grain is fixed, and we can only change it with force, like grinding it up into a powder. Bubbles in a fizzy drink. Gas. This is a tricky one because the drink itself is a liquid, but the bubbles inside it are made of a gas called carbon dioxide. Okay, so let's quickly remind ourselves of the states of matter again. Solids are made of particles that are packed closely together and can't move freely. Their shape is rigid and fixed, and can only be changed with force. Liquids are made of particles that are packed closely together but can move freely. They take the shape of their container and can flow. Gases are made of particles that are spaced far apart and can move freely. They take the shape of their container and can expand to fill their container too. In most cases, we can change the state of matter a substance is in by either heating it up or cooling it down. My friend Natalie was very thirsty, so she's already drunk her glass of water, but let's fill it up again. If we look at the water under a microscope, we can see that because it's a liquid, it's made up of particles that are packed closely together and can move freely. If we use a thermometer, we can measure the temperature of the water. It's currently at room temperature, or about 20 degrees Celsius. If we cool down the water to around -18 degrees Celsius by putting it in the freezer, its state of matter changes from a liquid into a solid. Water in its solid state is ice, and changing it from a liquid into a solid by cooling it down is known as freezing. If we warm up the ice back to room temperature by leaving it out of the freezer for a bit, its state of matter changes from a solid back into a liquid. Changing a substance from a solid into a liquid by warming it up is known as melting. The water is back in its liquid state at room temperature, or about 20 degrees Celsius. If we heat up the water to around 100 degrees Celsius by boiling it in the kettle, its state of matter changes from a liquid to a gas. Water in its gas state is steam, and changing it from a liquid into a gas by heating it up is known as evaporating. If we cool down the steam back to room temperature by placing a cold sheet of glass in its path, its state of matter changes from a gas back into a liquid. Changing a substance from a gas into a liquid by cooling it down is known as condensing. The ice, water, and steam are all made up of exactly the same particles, but by heating the particles up, their behaviour changes from a solid to a liquid and to a gas. By cooling the particles down, their behaviour changes back from a gas to a liquid and to a solid. Did you know that there are more than just 3 states of matter? Another state that matter can be in is called plasma, and you've probably seen plasma before without even realising. So we know that when we cool down a gas, it turns into a liquid, or condenses, but we can turn a gas into plasma by heating it up. This is known as ionisation, because when the particles are heated up, they break down into electrons and ions. If the plasma is cooled back down, it turns back into a gas. This is known as deionisation, because the electrons and ions recombine. Examples of things that include plasma are lightning, the sun, and even neon signs. What's really interesting is that not everything can be neatly labelled as a solid, liquid, or gas. A colloid is a mixture of multiple substances with particles in different states. For example, we can't simply label toothpaste as a liquid because it can't flow out of a tube without applying force and doesn't take on the shape of its container. But we can't simply label toothpaste as a solid either because we can't separate it into small solid grains like sand or sugar. Toothpaste is a colloid because it's a mixture of powdery solids like silica and different liquids like water. We can think of a colloid on a much bigger scale, like a bath filled with rubber ducks. We can't say that the contents of the bath is just a liquid or just a solid, but is a colloid because it's a mixture of liquid water and solid rubber. Colloids are so interesting because they act in very unusual ways. And to demonstrate that, let's go to the lab. I'm going to show you how to easily make a really fun colloid called oobleck. All you'll need is 1 cup of water, 2 cups of corn flour, or it might be called corn starch where you are, a mixing bowl and a spoon. You can also use some food colouring if you want, but don't worry if you don't have any, this will still work. Step 1. Pour the corn flour into the mixing bowl. Step 2. If you're using food colouring, add a small drop of it to the water. Step 3. Add the water to the corn flour and stir it well with the spoon. After a bit of stirring, you should notice the oobleck start to form and the mixture should start to get thicker. Now that we've made the oobleck, we can see that it looks like a liquid. We're now going to apply two different forces to it to see how it behaves. The first thing we're going to do is apply a very gentle force by picking it up and holding it still in our hands. Then we're going to apply a very strong force by hitting it with something hard, like our fist. Before we do that though, let's make a prediction. What do you think will happen when we apply a gentle force to the oobleck? And what do you think will happen when we apply a strong force to the oobleck? If you want, you can pause the video and make your own prediction, or keep watching and we can see what happens. Okay, so the first thing we're going to do is apply a gentle force to the oobleck by picking it up and holding it still in our hands. Ugh, yuck! It's very runny and is sliding between my fingers back into the bowl. Ugh. When we apply a gentle force to the oobleck, it acts like a liquid. It flows out of my hand very easily and takes the shape of the bowl when it drops back into it. The next thing we're going to do is apply a strong force to the oobleck by hitting it with something hard. I'm going to use my fist. Make sure to be very careful with this bit. Okay, here we go. 3, 2, 1. Whoa, that's so weird. This time it's very hard and bounces my hand back off it. When we apply a strong force to the oobleck, it acts like a solid. It has a fixed shape and doesn't run through my fingers. So why does this happen? If we do the experiment again and look at the oobleck through a microscope, we can see why it behaves in such an unusual way. Here we can see the solid cornflour particles are surrounded by the liquid water particles. When we apply a gentle force to the oobleck by picking it up and holding it still in our hands, the solid cornflour particles can move easily through the liquid water particles, allowing the oobleck to act like a liquid and slide between my fingers. When we apply a strong force to the oobleck by hitting it with something hard, the solid cornflour particles and the liquid water particles get pushed up closely against each other and can't move any further, allowing the oobleck to act like a solid and bounce my hand back off it. So oobleck acts like a liquid when we apply a gentle force, but it acts like a solid when we apply a strong force. Did you know that if you filled a swimming pool with oobleck, you could run on top of it all the way from one side to the other? Be careful though, if you stop running and stand still on the oobleck, you'll sink right through. Okay, so let's quickly remind ourselves of the three main states of matter one more time. Solids are made of particles that are packed closely together and can't move freely. Their shape is rigid and fixed and can only be changed with force. Liquids are made of particles that are packed closely together but can move freely. They take the shape of their container and can flow. Gases are made of particles that are spaced far apart and can move freely. They take the shape of their container and can expand to fill it too. If you want to keep practicing, download the worksheet in the video description, which includes instructions for making oobleck and experimenting with it. There are lots of foods that are actually colloids. What's your favourite? Tell me in the comments below. If you like this video, make sure to give it a thumbs up. Subscribe to learn more science, English and maths with Will, and let me know what you want to learn next by commenting below or emailing info@learnwithwill.co.uk.